Well, very good. So, good morning, everybody. How are you? I don't expect a response. I just hope you register that I care. I'm excited to be here. I hope you are as well. Right. So, we're going to go through a lot of stuff today. We're going to cover a lot of stuff in the world of Reactive Spring. So, I always like to start my talks with a little preface that we're going to go through a lot of things. The whole point of this talk isn't in 1 hour to sort of mint you as masters of all things Reactive in Spring. But it is more to sort of register what is possible and to see what's possible. And I know that since you are all very intrepid and entrepreneuring people, you'll be able to go out there and find the details. And I want to give you this GitHub repository as a sort of a first step. So that's out there on GitHub, github.com, Josh Long, FluxFlix service. And then there are, of course, guides at spring.io/guides, where you'll find all manner of different introductions to all things Spring and Reactive. And of course, if you have questions, don't ever hesitate to reach out to me. I'm happy to answer questions. I'm on Twitter. You can see that my coordinates down there at StarbucksMan. I'm happy to engage. Please find me there, and we can chat. And of course, if you have email, don't hesitate to find me there as well. So either way works. I am at your service. Um, I am Josh Long, as was just well explained. I'm a Spring developer advocate on the Spring team. I'm an open source engineer, a Java champion, and an author and trainer of numerous different videos and books. And I've just finished recently my seventh video, one of which is building microservices with Spring Boot live lessons. These are on the Safari online technical marketplace. And of course, I just finished my fifth book, and this book is called Cloud Native Java. It's all about how to build applications that survive and thrive in the cloud. And the book is an O'Reilly book. So if you've ever read an O'Reilly book, then you know that the most important part of the book is not really what's in between the covers. It's more the animal that is on the cover, right? That animal makes all the difference in the world for what people look to, what they expect to find inside the book. So this animal was a hard fought, chosen bird, but we found it after a long many years looking for it. Right, this bird is a blue-eared kingfisher. It's a bird that is indigenous, or of course, as we'd say in English, native to the Indonesian Java Islands. It's a bird that's indigenous to Java, or native to Java. And birds, they fly. They fly often through the clouds. So this is a bird that is native to Java that flies through the clouds. It's a cloud native Java bird. It's a bird, and never mind. Anyway, you'll get it. It'll come. There's that. And it's a blue-eared kingfisher, right? So that's a cool bird. And of course, I work at Pivotal, and at Pivotal we have a lot of great open source software. We care very much about open source. Let's be very clear about that. But it is not the thing that drives people like me to spring out of bed. What we care about more than anything is to help organizations, customers, community members, etc., build better software faster and safer. And as part of that, we talk to organizations about how to increase their agility, and sort of a side effect of that progression, that movement, that optimization for organizational agility is this move to microservices, right? Microservices allow organizations to decompose their large monolithic applications into smaller batches of work, a small batch of work upon which a small team can iterate and then deploy into production. And this has tangible benefits. You see, the act of decomposing your software into small, singly focused, internally consistent, reusable, independently deployable batches of work allows small teams. It enables small teams. That is to say, you don't need large teams working on one large monolithic code base. You can have lots of small teams, each focused on one deliverable. And that small team, by virtue of the fact that it's staying within its own component boundary, has the ability to go faster, right? As long as the surface area component boundary of the component remains stable, then the rest of the organization only needs to know about the API. They don't have to have long and tedious communication sort of interactions, right? Conversations, email threads, that kind of thing, that gate our ability to go faster. We can all sort of stay in our own proverbial swim lane, right? That allows for agility. The problem that a lot of people face when they move to this architecture, of course, for all of its benefits and ability to help organizations go faster, is that, of course, when you move to this approach, you're now introducing, the complexity of building a distributed system. Lots of small services talking to each other over the network, and of course, there are patterns that you need to know about that address reliability. There's things you need to care about in terms of the ability to scale out. There's all sorts of things that you need to care about that weren't necessarily problems in the world of the monolith. One thing that we see a lot of people struggling with is how to get the most efficiency out of their individual services, right? What we want to do is to be able to move a lot of data across the wire as efficiently as possible, and want to do it as reliably as possible. And this is this is a two-pronged problem. The hardest part, I think, is getting the efficiency right. The efficiency is something that we can take for granted at some point because we can scale out, but at some point we need to become more efficient in the way we handle individual interactions, especially as we start to move more and more data per request. And this requirement to send a lot of data, a potentially unlimited amount of data across the wire, becomes more and more pronounced as we scale up. So what we're faced with is a very fundamental question: how do I move large amounts of data from one node to another? How do I facilitate that mostly I/O bound interaction between services? And this isn't a particularly new problem, right? We've had in the Java, we've had in the computer industry, in the computer science industry, we've had a lot of different support, a lot of different options here for managing this kind of complexity. And in the Java world, of course, we've had since day one the JDK input stream and output stream abstraction. Now, these input stream and output stream abstractions have served us well, but they are a very, very simplified abstraction. They hide some of the intrinsic power and complexity, fair enough, but they also hide some of the power of the underlying input and output model in the operating systems, in most operating systems, right? Network I/O at most operating systems is asynchronous, right? Whereas the input stream and output stream present a synchronous facade. So fast forward to JDK 1.4, and you get Java NIO. You get channels. You get file. The ability to talk about asynchronous data that will eventually arrive. And this gives us the ability to start thinking about this. To start saying, I have data that's coming in on a socket, and I need to be able to respond when and only when that data is available. And so this, with channels, you have the ability to say, give me a notification, and in the meantime, you're no longer blocked, right? That whatever thread, whatever processing thread, even if it's just the main thread, can do whatever else it needs to do while it's waiting for that channel to give it a notification. And so this is what we want. This kind of functionality is what we want, is the ability to talk about the fact that data is incoming, but we have other things to do, right? It gives us the ability to unblock our interactions and thus to be more efficient. We can do more with the same resources. That said, this is a very low-level programming model, right? We didn't, and we still don't, write most of our business logic and our functionality in terms of input streams and output streams. So why would we any sooner move to JDK and IO and use channels and so on, right? So this is it's not quite suitable. So what we've looked for the last 10 years, is some way, some paradigm to model this kind of interaction. This idea that we have work that will arrive, that will happen. It'll happen asynchronously in the future, at some point in the future. We don't know when, and it could imply a lot of data or a little bit of data. But the point is, we can't be constrained, and the program shouldn't have to change depending on the size of the data. So we've looked for some sort of paradigm to address this, and I think you've seen a lot of really innovative work in this space, right? I think the 900-pound gorilla, of course, is the work done by Microsoft Research around the reactive extensions for .NET. That, of course, then inspired the folks at Netflix who built RxJava, and very shortly thereafter, you see a sort of deluge of different options in the ecosystem. So you've got the folks at Lightbend, nay, of course, TypeSafe, who built akka, and that's one way to sort of address this kind of need. And then you have companies like Red Hat, which have a technology called Vertex, and of course we on the Spring team, both at VMware and now, of course, here today, we have a project called Reactor, and Reactor is a framework for modeling this sort of missing piece, right? The missing quarter of the quadrant of types of values that you can get back. So think about how you would model in the JDK today a service that's returning a single value of type string. Let's say you'd say, I have a method and the return value is string. And if you had a method that returned multiple values of type string, T, right, you'd say collection of string, right? Collection generic type string. And if you have,
I'm sorry for interrupting you. There's some question about the slides. So right now we see only the first slide, and
yep, it says pivotal and Spring and Cloud Foundry.
Right. Is that what?
Yes.
Okay.
I don't do slides. I have to get through this. Okay.
Perfect. Thank you. I just want to confirm it that it's not free. Then sorry for interrupting.
Okay. No problem. So we then have this. We have multiple values. We have a method that returns multiple values. We say that's a collection of string. We have a method that returns a single value. That's a string. If we wanted to have a method that returned a single value asynchronously, we'd say, using JDK8, we'd say here's a completable future of string, right? So this is a mechanism that allows us to get a notification when the value is available, even though it's not right now, right? It's not a future. It's better than a future. I don't have to poll. I don't have to constantly ask for the value. I can just be notified, when it's available. And that gives us 3 out of 4 of the kind of things that we want to model. What is missing in this paradigm is how do we model, how do we describe, how do we talk about a potentially unlimited amount of data that may be available later on in the future asynchronously, right? And this is what's been missing. And I think a lot of us in these different sort of corners of the ecosystem have been looking for ways to address that. And here you can see that there's been a lot of different ideas, and we all sort of converged upon the ideas that we put together in the Reactive Streams initiative. So the Reactive Streams initiative is a sort of de facto standard that describes this missing piece. In the Reactive Streams initiative, you have it's basically a specification, a very, very tiny specification. We describe 4 types, 4 interfaces. The first and most important, I think, is the publisher. A publisher is an object that produces values to which a subscriber, that's another interface, may subscribe. And in so doing, a subscription is created. So you have 3 interfaces there so far: a publisher, a subscriber, and a subscription. And if you have a component that produces values, that is to say a publisher, that also then subscribes to values from some other publisher, then you have something called a processor. And a processor is our 4th interface. That's it. That's the entirety of the Reactive Streams specification. Now, this may seem enticing, and you might be tempted to rush out and to try and implement these interfaces and call yourselves reactive, but I assure you this is a very bad idea, right? There's a lot of convoluted work that has to be done at the lower levels to make this happen. So we have, thankfully, luckily, we have an abundance of options here in the ecosystem, right? The Reactive Streams specification has been implemented by, of course, our own project Reactor. The Akka Streams project at Lightbin can use it as well. Vertex implements it as well, and of course, RX Java 2.0. So we have now here a mechanism for interoperability, and of course, that work then inspired the sort of JDK 9 flow module, right? So that's another channel by which we can see this missing piece being addressed. Now, Reactive Streams gives us a very, very low level understanding, a single type or a single set of types, a very small set of types along which we can sort of agree. But it's, I think, by itself not all that useful, in the same way that arrays are valuable as a common transport mechanism, as a common way to query data back and forth from one component to another. It's still very low level. We tend to do more interesting things with our data than just store it, right? We need to be able to process it, to transform it, to filter it, et cetera, et cetera, et cetera. So we look for higher order operators, DSLs, things like that can serve us there. And here, Reactor comes into its own, right? We have a very rich set of APIs, a very rich set of capabilities in the Reactor project. Now, is that enough? I'd still say no. Reactor in of itself, while very interesting, is focused on being a reactive runtime. It doesn't necessarily address the concerns of higher order functionality, like building web services and data access and security and so on. And here is where our story begins. You see, we just last week released Spring 5, and Spring 5 has a number of great features, including JDK 9 support while having a JDK 8 baseline. It includes support for Java EE 7 and Java EE 8. It's filled with great features, but my favorite feature is the support for building reactive applications, and that starts at the web layer in Spring Framework 5, so where we've introduced a new runtime. So we're going to talk about all that stuff today. Now, going back to this idea, going back to the project Reactor, it's important to understand that Reactor bases its two main types on the Reactive Streams publisher type. So we have two types in Reactor. One is called a mono. A mono is a publisher that is bounded. It's either 0 or 1 value, right? So you have no value or you have 1 value. It's still a publisher. It's just a publisher that can only ever produce one or the other. Now, of course, you can still handle it in terms of the publisher contract, in which case all your consuming code would be none the wiser. It's just that they would only get 1 value. Another type that we have is called a flux, F-L-U-X. It's a publisher that produces 0 to n values. And the reason that these distinguishing types are useful is mostly for documentation. It's mostly for giving a cue to the consumer about what the intent is. Imagine you're trying to render a screen, and the screen has a text box. That's probably going to use a mono, right? Versus a grid. In this case, you can expect to use a flux, right? Otherwise, you wouldn't have any idea about what to set up, what to look for here. Now, this gives us fertile ground for some interesting apps. And while we could build any number of conceivable apps out there, I want to keep our domain as simple and trivial as possible. So I like to. I was thinking about this with my friend Mark Heckler the other day. We were thinking about having some sort of sample app, some sort of app that we could use on the internet, right? What if we had some sort of app that allowed us to talk about and interact with movies, for example? Now, in English, it's a colloquialism to say that when you have one movie, it's a movie. If you want to use slang, you can say it's a flick. If you have multiple movies, we call those flicks, right? And so we're thinking, what if we had some sort of service? And again, hear me out. This might be a little crazy, but what if we had some sort of service where we could work with flicks and interact with flicks over the net? And again, I know this is preposterous. So, but again, just hear me out. We want to have some sort of service to work with flicks over the net. And we were thinking we could call it Netflix. What do you think? Because of Reactor and Flux and no? Okay, well, anyway, we're going to go with that. And we need to build a new service. And of course, I'm going to use my favorite tool to do the job. I'll use IntelliJ, right? So I've got IntelliJ here. Now, normally at this point, I take us to start.spring.io, and that's a great place to start. But if you're using IntelliJ, which I expect a lot of the people in this audience are, then there's a very handy little option here, Create New Project. And Create New Project opens up a wizard. And when you go to the wizard, you are given a chance to point at a particular start.spring.io permutation. And there, we can specify the name of our artifact. So Flux Flicks Service. And we're going to make this a Kotlin project just because it's fairly straightforward if you know Java. And I figure this is a good chance to demonstrate it. And then we're going to hit next, and that'll show us all the options. Now here, I want to choose Spring Boot 2.0 snapshot. So I'm going to use the latest and greatest versions of Spring Boot 2.0. Now, Spring Boot is a fully integrated reactive framework. It's going to be released in December of this year, we expect, and it'll all the other stuff that we've done in the ecosystem bubbles up into this release. So Spring Framework 5, which of course was released last week, Spring Security 5, Spring Data K, Spring AMQP, all the other things that have reactive support, that'll bubble up into Spring Boot 2.0. So we're going to use here reactive web support. We'll use reactive MongoDB. We'll use reactive security. Now we have here, I chose reactive MongoDB. Let's take a look at those options again. Here we have reactive MongoDB, reactive Cassandra, reactive web, and reactive Redis. Now there are a number of different and very good options here. But so far these are a subset. By definition, they're a subset of the supported options. First in Spring Data. So Spring Data, of course, is the umbrella project that we use to address NoSQL sort of interactions and data processing functionality. And because even in Spring Data, we have one more option that we don't have here surfaced in our Spring Boot auto configuration, and that is reactive Couchbase, right? So that's not here yet, but it will be. And then even that is a subset, of course, of what Spring Data itself supports. You may know that Spring Data supports any number of different other technologies, including most notably JPA. Now, JPA is a ORM framework. It's an ORM technology. It's a standard. It is often based on things like Eclipse Link and Hibernate. Well, we don't have at the lowest levels of JPA, the ability to do reactive programming, right? JDBC is a blocking API. Now we could create a reactive facade on top of this fundamentally blocking thing, but we're of the mind that that's sort of fundamentally not very useful. It would be just as imperformant as a blocking API while being different. We'd have to change things just to get nothing, right? To get no benefits to it. So we're not going to try and do that. We're not going to turn those things around. Now we're inspired. I think we're all hopeful about the recently announced reactive JDBC work being done by Oracle. The details of which they began to announce just in the last few days at Java 1. So that's interesting. We'll see where that goes. But for now, we're going to use the technologies that are properly and fully reactive. So we're going to stick with reactive MongoDB. Now, again, a number of different choices here, but reactive MongoDB works just fine. So we'll hit next, and we'll get ourselves a new project. Hit go. All right. So we have a new service, and the first thing I want to do is I want to disable the security here because that's not going to do anything for us just yet. So let's go back to our build, and we'll build a new service. So here we are, Spring Boot Starter Security Reactive. Everything else is as we expected. You'll notice that the Spring Initializer automatically supports Kotlin. So we have Kotlin support there. We have the Kotlin STD, standard library. We have the runtime, etc. We have a Kotlin compiler plugin all plugged in and everything. I mean, everything has just been set up for you, so we don't have to worry about anything else. Now we can go to the code and start building an application. So the first thing that we're going to do here is we're going to build a data model, right? We're going to build a model to talk about movies. Now this is a regular Spring Boot application, so if you haven't seen Kotlin before, this is basically the public static void main entry point into the application. In Kotlin, the name of the variables on the left and the types on the right, so it's args, colon, array, string. But otherwise, this should look, I think, altogether very familiar if you've ever used Spring Boot. So let's see. We're going to build a type to model a movie. Now, this is going to be a movie that has a couple of fields. I could just do this. I could say var ID equals string. So the type is string. And I want the type to be nullable. So I want it to be like that. And I want it to have a default value of null, right? So var, in this case, tells Kotlin that it's a mutable variable. I can change it. So I could do that, and I could create getters and setters if I wanted to, but this is a lot of work. What I really want to do is I just want to let Kotlin do that work, because all I'm trying to do is to get a Java bean, basically. So instead, I'll say var ID string question mark equals null. Okay, and I'll say var title string question mark equals null. Now, this is my basic Java bean. I want to make it a document, so I'll use the Spring Data document annotation here. And I'll say at ID. There we are. So that's my entity, right? That's going to be a Spring Data MongoDB document that'll have a primary key kind of thing, a key called ID, and the default values are null, and they are nullable. It'll have getters, it'll have setters, it'll have all that. Now I want to make this a data class, right? That'll go one step further. It'll give me a nice equals and so on, things like that I can use to support equality. Right. All right. So now I've got a movie, and what I want to do is I want to be able to persist or interact with instances of this entity with the underlying data tier, in this case MongoDB. So I need to write a repository. A repository is a design pattern designed to support the data management lifecycle. So I'll say movie repository. Okay. And we're going to extend the reactive Mongo repository. Now, the reactive Mongo repository, just like any other repository, expects two types. It expects the type that we want to interact with. This is a movie, and the type of the primary key. Now, that's it. I don't even have to do that, right? This is enough to get what I want. Now, this reactive Mongo repository is the same as any other repository you've probably seen in Spring Data, except that the return types are these publisher subtypes. There are monos and fluxes and so on. And further, they accept publishers, right? So we can accept a publisher and return a specific type of publisher. So we get all that for free. Now we can save some sample data in the database. Now, I'm going to have a bean here, a bean of type runner, and this is going to be an application runner. So I'm going to create a Lambda here. This is a great callback interface that Spring Boot provides, and the callback interface has one method, void run. Now, of course, in Kotlin we can create a Lambda that addresses that, like this. Now the void run method has arguments here, right? We can choose to, since we have just one argument, we couldn't choose to create a parameter like that, or we can just leave it alone. If we don't specify it, it'll be available through the implicit parameter here called it, right? So there's the it variable, and since we're not even going to use it in this case, it really doesn't make any sense to care about it. So let's now write some sample data to the database. So movies equals, we're going to create a flux here just of some sample data, and I like to use data that's on the theme of reactive programming, the theme of functional reactive programming. So we're going to create some movie titles here based on those themes. So how about this one? This is from our friend, the one, the only, the amazing Phil Webb, the co-founder of Spring Boot. It'll be Silence of the Lambdas, right? That's a good one. Or we can use that movie. There's an anime with the word flux in it, so we can say Aeon Flux. There's a movie where they talk about a flux capacitor. That's Back to the Future, right? So a number of different options here. If you think of some others, please don't hesitate to send them out on Twitter. I'd love to hear them. So here we are. There's a publisher of 3 strings. I'm going to turn those 3 strings into movies. So I'm going to say that I want to save the data. Now, of course, I want to save the data using the movie repository. Here we are. So I'll inject that as a collaborating object, and I'll say mr.save movie title equals it. Remember, that's the implicit parameter here for this lambda. And since it's a parameter and it's a lambda, I don't have to actually encapsulate this method call with parentheses, though I could, right? It's just a syntax shortcut here. So there we go. I'm saving each record. Now that gives me a publisher of movies, all right? And I can see as much, I can confirm as much as I want by assigning this to a type, right? It's optional in this case. It'll do type inference, but for our purposes, it's just useful to know that. Now we're going to save all this data, but before we save all the data, I want to delete all the existing data. So what I want to do is I want to say delete all. Now I want to make sure that this happens before everything else. So one way I could do that is to say block. Now this is a terrible idea. I showed this code to my significant other, and she looked at me like I was not very bright. So don't do this. This is a terrible thing. You've got this wonderful reactive API, and here we are blocking. What we want to do is we want to say delete everything, then process this publisher of movies, right? So we've got movies, and then we want to let's see. We want to say that we want to return everything that comes back from the database. So I want to return everything. There we are, and then we want to subscribe. And this last method is the most important. What we're doing is we're saying when you have finished building up the graph of operations here, right? I'm building a reactive pipeline, if you will. These first 3 operations are a pipeline. I'm saying do this, then this, then this. Nothing happens until something subscribes to it or blocks it, right? So, and blocking ultimately just subscribes. So what I'm doing is I'm kicking off the pipeline. I'm executing the definition here, and I'm telling the publisher that I'm interested in getting the values that it can emit. So here we are. We're going to print everything that comes back on the console. Okay. So now let's run the application. All right. So there we are. There's our application with the 3 records on the console, and that seems to have worked. So good. Now we can create let's create a service, right? What we ultimately want to do is create a web endpoint. But in order to do that, let's build a service that surfaces our business logic. So we're going to create a movie service like so, and the service will in turn inject or work with the movie repository. So we're going to say private val mr movie repository, and the service is just going to surface higher order business logic, right? So we're going to say that we have an endpoint here that returns all the records. So I'm going to say mr.findAll, and we'll have another one that says that we're going to return a particular one by its ID. So there's this mr.findById. And for this last endpoint, what I want to do is I want to have an endpoint that can return the events. Let's suppose I had the opportunity to somehow log into the service and tail all the logs reflecting all the output from all the services. That would be very interesting, I think. By the way, I don't mean to go past this too quickly. If I'm, there's no statements in this language, right? So everything is an expression. So here I have a method that is returning a single value. There's no need to create a parenthesis, and all that stuff. I can just and I can just say the result of this method when you call it is the statement here, right? And of course, in the reactive world, you can chain these methods very nicely. So you get one long statement or one long expression that gets returned back. That's very convenient. Now, this last endpoint here is going to be, as I say, an endpoint, a service that allows me to look at all of the activity for a given movie, let's say. So I could see who's streaming the videos. I could stream the information about people who are streaming all the videos. Now, of course, I don't actually have yet a bazillion users logged into the system, looking at the output of the, looking at all the different movies. And so we have no real sample data. So let's just fake it till we make it. We're going to stream all the streams. We're going to cross the streams, to borrow from Ghostbusters, right? So we're going to say fun events, and we're going to look for all the events for a particular movie. And what we're going to do is we're going to synthesize a new new record. Okay, and the movie is going to be the record of is going to be of type movie event, right? So this is going to be yet another data class. It'll contain two things. It'll contain the movie ID string $? null, and it'll contain the date, right? Now we could use the name when, but this is actually a reserved word. So if you run into this, if you find a variable name that is now a reserved word in Kotlin, it's a backtick, right? But for our purposes, let's just keep it as date, since we don't really want to be in a situation where we're doing things that the compiler wants to do for us or do otherwise. So we're going to call it the movie ID, and we're going to give it the date, and they're going to both be nullable and default to null. Okay, so this is our wrapper type that will describe both what movie is being watched and when it was being watched. So we're going to generate now a series of data. We're going to use a callback here that expects a sync, and the sync is a synchronous sync of type movie event. And in the sync, we're going to generate a new value. So I'm going to say .next, creating a movie event. And we'll pass in, of course, the movie ID and a new date. All right. Now that's going to create a publisher that will have a continuous, never-ending sequence of movie events. As long as there's heat in the universe, there will be movie events, which isn't exactly what we want, because I want to be able to. I mean, we're not going to have a trillion users watching movies every microsecond, right? We're going to have a stream of data. Now, let's say that we have a moderately loaded service, and so we get a new stream every second. Since I don't actually have all those users logged into the system, let's take advantage of the fact that behind the scenes, behind this wonderful reactive reactor API, we have a scheduler, right? So we're going to actually tell the scheduler to delay the elements that are coming out of this publisher by a certain amount of seconds, right? So there's our delayed publisher, and I think that's it. I think that'll give us our very simple service, and we can use that to build a REST endpoint. So if we go down here, we can say want to build a Spring MVC style REST controller. Now this is going to be very similar and very familiar to anybody who's used Spring MVC before, but this is, let's be very clear, not Spring MVC. This is actually a net new runtime called Spring Web Flux. Spring Web Flux is a brand new web runtime. It has similar support. It has annotations that are similar to Spring MVC, except that it's fully geared from the ground up to be reactive. It's to support reactive processing. And so some things are going to be very different. Notably, this is not based on or does not require the servlet API. It uses a brand new web runtime based on Netty that we built. Now you can run the Spring Web Flux API on top of the servlet 3.1 or better environment, and it'll be okay in certain cases. But of course, there are some parts of the servlet API that are inherently blocking, and there's just nothing we can do about that. So while we have a facade on top of it, and while it does work fine for the request and response use case, some parts of the API, some corners of the API will not be truly reactive, even though we've got the R abstraction on top of it. But this is a nice feature of Spring Web Flux, which is that you get the portability. You could run this on top of something like WebSphere. Now, I don't necessarily recommend that you do that, of course, but the point is you could if you needed to. But you'll find that we're actually using there's a Netty but blocking Netty context here that's being spun up for you by default. So let's create an endpoint here. We're going to say public by ID, and this will be It'll take a movie ID, and we're just going to delegate to the service there. So there's that. And of course, this is a web endpoint, so get mapping movies, curly bracket ID, and this becomes a path variable. All right. So we want to have that. We want to have an endpoint here that returns just all the movies, right? There's that. So fun all equals ms.all. Good. And we want to have one more endpoint that returns the data coming back from the events endpoint, from the event service. So we're going to say movies ID events. Now, this would seem to be fairly straightforward, I think, but there's a bit of a problem with this code, isn't there? Like, imagine I wrote this code. Imagine I run this code. What's going to happen, right? This code, by default, we're going to get JSON. We're going to, it's the content. The client is going to send accept headers that indicate that we want application JSON of some sort. So the service will dutifully respond, and it'll send us back JSON. But of course, here, the client isn't prepared for a JSON document that never stops, right? This JSON structure is going to keep going forever and ever and ever. So what we need to do is to signal to the client that this is data that will never terminate. And if a client knows of the protocol of the content type, it'll do the right thing. So we need to give it a clue as to what's gonna happen. We need something that is geared for this, right? We could use a number of different things. We could use WebSockets. WebSockets are, of course, a bidirectional protocol that allows us to push down data down to the client. So as long as the client has a socket open, it'll expect to receive new data, and it'll cycle it back to the client as fast as possible. And that's certainly easy enough to do. There's a Spring Tips installment, a video I just recorded a few weeks ago on that exact topic, on using the reactive WebSocket support in Spring Framework 5. But for our purposes, it's simple enough to just signal that we're going to be producing data that supports service and events. So what I'm going to do here is I'm going to say, send back the media type for text event stream values. Okay, so there's our REST endpoint plus one extra type of endpoint that supports service and events. So let's go ahead and restart the service. Open up the browser here. Now, one thing that's peculiar about what's happening here is that because I'm recording, this computer is crawling, just sluggish. So, curl HTTP localhost 8080/movies. Okay, there's our records, right? And we can see they're all there. Now we can look for a particular record here. Let's just grab this ID, copy, curl. Well, let's grab that one. There we go. Okay. There's that single record. Great, that seems to be okay. And there's something wrong with that. Let's see. Oops, forgot to specify the path variable for the events endpoint. So we'll try that again. Now the error you saw was that the parameter was specified as non-null, and of course it was sent to us as null. And that was actually that's a nice, the language itself signaled that it was supposed to be non-null. So we got an exception running to that. So there's our movies, and here's the parameter. Here's the events. And there we are. There's our different data being sent back to the client. Now, this is using message framing. You can see that each new record is delineated by a data colon preface, and then a new line and a new line at the as a suffix. So we have now our endpoint. Now, this is certainly one way to write the endpoint. It's fine if you're coming from Spring Web MVC. This will feel very familiar. But there is a new endpoint that we could use here as well. So we're going to build a new endpoint using the functional reactive support in Spring Webflex. So we're going to say web configuration, and we're going to inject the movie service here. I guess we don't need the val. We need val. Okay, Alt Enter. And so this is a configuration class. It's a Spring. It's a class that will produce beans. It's a bean provider, if you will. So I'm going to create a bean provider that produces a set of routes. So here we could use the router function type from Spring Webflex and so on. We could do all that and create a request predicate and so on. But we don't really need to do all this, right? There's actually the final parameter here is a handler function, and if you had provided a handler function, that would be enough. But this is the Java API. There's actually a Kotlin native DSL in Spring Framework itself, right? So it's already on the class path. All we have to do is to use the router DSL here. So we say router, and we can describe some interactions. So the first endpoint is called movies, and it's expecting a lambda here on the other side. So we create a lambda, and again, I could create a lambda that has the parameter. Right? I could acknowledge that, but I don't need that parameter, so there's no point, and it'll be given to me as an implicit parameter anyway. So what I'm going to do is I'm going to say when somebody asks for all the movies, I'm going to use the router service, the movie service that I've got there. I'm going to say server response dot OK dot body equals ms dot all, and I have to specify here for the second parameter the type of data that we're sending back to the client, so class Java. That is our one handler, right? We can duplicate that for the other three endpoints here. So let's see, movies ID, and here we're going to say give me a record by ID, and I can just say int.path variable where it, of course, is this, in this case, is the request. And here I want to get the movie events. I'll change this to be a movie event, and this will be events. And we'll say it.path variable equals ID. Now, what we have is that second parameter is telling the web runtime what type of data we're sending back. So consider what's happening here. We're sending back data that may be, potentially very large. In the last case, it's never ending. And the first two, it could be billions of movies. Not that there are a billion movies, I guess, but it could be. Is my point. The runtime has no idea, and so it needs to know when to frame the message and then sort of send that back to the client, right? It needs to eke out and emit as many values as it can whenever opportunity it gets. So what we need to do is we need to give it a clue as to when to do that, right? So I forgot to give that a content type. So we need to give it a clue as to when to do that. We're telling it to do so every time it finds a record that can be considered a movie or a movie event in the case of the last endpoint there. And we're doing that explicitly here because it has no way of figuring that out from the response, from the values that get sent in from the service, right? The ms.events, ms.byid, etc. It doesn't know because at runtime, in the JDK, in the JVM, generic parameters are lost. So we need to be explicit about that, right? So we're telling it this is a publisher of type movie, and so every movie you can send back the data. All right, now let's go back to our console here. We can say curl http localhost 8080/movies. Good. And paste, and then we go to the events endpoint. And there we are. There's the same service re-implemented using the function reactive endpoints. Now, which one should you use? Well, it's entirely up to you, I think, right? A lot of people like this style. And if you've ever used Sinatra in the Ruby on Rails world, or Scalatra, or Spark Java, this might be more familiar to you. If you're coming from Spring MVC, this might be more familiar to you. Whatever style you like, we don't have a strong opinion. This just seems to be a very useful thing to have in the sort of reactive function reactive world. All right, so we now have a web application talking to the internet. We have data. We're talking to the data tier. This is still, at the end of the day, just a toy, I think, however, because we've kind of ignored some of the very real concerns that people have to care about when they move to this approach. So one thing that we care about when we move to this, when we move an application to production is observability. I want to be able to understand what the application is doing. I want to be able to surface information about the application so that I can monitor it, I can inspect it at runtime. And so I have neglected, in this case, to bring in a library from Spring Boot called the Spring Boot Starter Actuator. So I'll bring in the actuator. And actuator is not a new thing. It has nothing. There's nothing new about it or specific to the reactive support, except that it was previously written in terms of the Spring MVC sort of web runtime, right? And so that support is now available for Spring Web Flux, and indeed it's also available for JAX-RS. So you'll see that that's a nice feature, is that the actuator endpoints have been decoupled from the web runtime that's in play here. So it could be Spring MVC, it could be Spring Web Flux, or it could be JaxRS. So okay, there's our Spring Boot actuator. We're gonna activate it by using this property endpoints to disable that, or the endpoints default web enabled equals true. We can run the code here, but before I do, I also want to address security. Right, this is another concern that we have to care about in a production environment. So I'm gonna go back to my build, and I'll bring in Spring Boot Starter Security Reactive. Okay, so there's this, and we're not going to do too much to make this work. You could do all sorts. Spring Security has at its heart the concept of an authentication manager, and then on the other side it has an authorization manager, basically something like that. And these two interfaces handle authentication and authorization respectively. If we set up a default, if we set up an object of type user details repository, Spring Security will assume that we want to talk to whatever data access layer based repository object that we give it to answer questions about users that are coming in and making requests into the system, and it'll automatically lock down everything using HTTP basic. So authorization will be done automatically. If it's authenticated, it goes through. Otherwise, it's not, and it'll be HTTP basic. You can configure that in more detail, but since we're short on time, I'll leave that to your imagination. So let's just do some basic Spring Security here. Basic Spring Security 5. We're going to say we want to enable WebFlux security. I'm going to create a bean endpoint or bean definition that describes our users. And again, we're going to use that, the user details repository abstraction that Spring Security 5 is looking for here, right? This maps more or less to the user details service in classic Spring Security and synchronous blocking Spring Security. So we've reworked a lot of things in the Reactive Spring Security support to allow it to work in this world. Because think about it, the last thing that you want to do is have all this beautiful reactive code only to be deadlocked at a thread local, right? Blocking synchronous thread local, where of course that makes very little sense in the reactive world. So we're going to say that the username is rwinch for, of course, the one and only Rob Winch, the lead of Spring Security. We're going to give him the role of admin and user, of course, and we'll build that out. Now, I can also build another user here with username jlong.password equals pw.roles equals just user, and we'll build that one as well. All right, so there we've got two hard-coded users. The user details repository the contract is very simple. It is just given a username, return a publisher of type user details, right? So there's our simple user details repository that we're returning. When Spring Security is activated, that'll be used to lock down the system. So let's go ahead and run this code again. Now, we could, at any point, configure another bean that returns an HTTP security filter, basically, and that would give us the ability to configure authorization. But for our purposes, it's fine to leave it as it is, as I say. So let's create a shell, and we'll say curl HTTP localhost 8080/movies. Now what I'm gonna do is I'm gonna go to the beginning here. I'll say I want to see the verbose results. Okay, and so there you go. It says 401 unauthorized, right? We need to authenticate. That's fair. So go to the beginning, and we're going to specify -u. That's the username and password for our curl command, and the user will be jlong, and the password will be pw. And there we are. If we do that and then pipe that out to JSON PP, we can see we get the JSON data, right? So there's no error as well. So that works. Now, one of the other things that we just added were those actuator endpoints. Now, as I say, actuator serves a very common goal. You see, it doesn't matter which organization you are, doesn't matter what technology stack you're using, doesn't matter where in the world you are and what business vertical you're in. One thing seems to be surprisingly consistent. When the pager goes off, somebody gets roused to a computer and has to figure out what's going on. Their job is not root cause analysis. Their job is to triage whatever's happening and stop the bleeding, right? So everything we can do in those waning seconds in the dead of morning to help that process along is valuable. So the actuator serves that goal. It surfaces information about the application. And while there are a lot of number of other sources that you can get insight about your application, there is nothing better than your application itself to articulate that state. So here you can see we have in the actuator a health check. Let's pipe that out to JSON as well. And the health check tells me my connection to MongoDB. It tells me about my file system connection, and it shows me that these things are up. And if they weren't up, then of course the status of my application itself would be imperiled, and we'd see that reflected here. We'd say status equals down. I won't spend too long on the actual endpoints, but suffice it to say there's a whole number of them, and they all work nicely in a reactive world now. All right, so we've got a secure, reactive, observable application that's got a web API. We've looked at 2 different ways to write the API, and it's talking to a data tier. And we also looked at Reactor, but this wouldn't be much of a service without a client. So let's go back to IntelliJ, and let's build a new client module. So create a new project. Next, we're going to call this the Flix client. We'll use, let's use Java this time. There's no reason not to. It doesn't, both are nice languages. They both work just fine, of course. So hit next, and we're just going to use reactive web, right? So here we are. Oops. 2.0 M4 and reactive web. Hit next. Hit finish. New window. All right. So the first thing that we need to do is, of course, to move this to a separate port. So we're going to say server.port equals 8081, and then we'll use the Flix client application.java. And here, all we're going to do is just create a client. So we're going to create a web client to talk to the service. And we could use the Spring Framework REST template, right? The REST template is certainly an interesting option here. But the problem is that the REST template is synchronous, and it blocks, and it's not particularly geared for unlimited amounts of data. This would be a very hard thing to manage. We could call those first 2 web endpoints with, not too much trouble, assuming there's not too much data. But we'd run into trouble when we call the last one, the service and event endpoint. So let's create let's use the new web client that's introduced in Spring Web Flux. We're going to create a web client, and we're going to prefix all of its calls to 8080/movies, and we want to mutate it. We want to mutate it because we want to configure a filter, right? So I'm going to say exchange filter function dot whoops. Filter. Well, did I? I have done something. Let's see here. Cat desktop mask on Flix client source main Kotlin. I just wrote this code before, so I know that exchange filter functions basic authentication. That should be all we need. Let's see. All right. There we go. I should have created it first. Okay, so get rid of that. There we are. Now we're cooking. So what we're doing is we're saying we want to create a new web client. We're going to prefix all the requests to localhost 8080 movies, and we're going to create a filter that does basic authentication for JLong and PW. Now we're going to use that client here in our application runner. So we're going to say application runner, and we're going to inject the web client as a parameter here, right? So what we're going to do is we're going to say web client dot get dot URI equals, and of course there's nothing to get, right? We're just going to call all the records. We're going to retrieve the data. We're going to turn it into a type of movie. So I'm going to say class movie private, and of course here it benefits us to have Lombok, right? So I should have added that to the class path. Thankfully, we already got the Lombok plugin installed, so all I need to do is to add that to the class path, and I can say at data, and I'll say I want private string ID, private string title, and this will create an all argument constructor and a no argument constructor. All right, so there's our basic type, and we also want a type to describe the movie event, right? So we'll say we have a movie event, and this will be a it'll have a string called the movie ID and a date called date, right? There we are. So there's our basic structures from the server side for the implementation, and we're just creating the details in the client here, so that we have something with which to work. And we're going to say we want the body of all the requests to come back as a movie class, and we want to filter a particular movie. I'm going to say, give me the title, and if the title contains one of these movies, let's see, we can say we want that, and then we want to flat map that one result and turn that into another call to the events endpoint, right? So ID events, passing in, of course, the ID itself from the movie, and then we want to turn that into a request that we then turn into a body of flux of type movie event.class. And let's see what is wrong with that. So we're going to say, oh yeah, this is the URI body to flux. I turn a args. All right. And then finally, of course, we want to subscribe. So I want to say, call the system out print line method each time there's a new record that gets returned from that. So let's now run this code here. Now, when this runs, we should hopefully see that it's making a request, an authenticated HTTP basic authenticated request to the localhost 8080 movies endpoint, and then it's going to get the data, find the particular record that we're interested in, and then stream the movie events as we have them in the server side. And there we are. So with that, my friends, we've got just a few seconds, maybe 6 seconds until we're at the top of the hour. We've looked at Reactive, we've looked at Spring Web Flux, we've looked at the functional reactive endpoints, we've looked at the Spring MVC style endpoints, we looked at Spring Data, we looked at Spring Security, we looked at the actuator support, and we looked at how to build a web client. There's also fully integrated testing support, and also, let me reiterate, this is just the beginning. The release of Spring Framework 5 has already set off a series of dominoes of new releases, all integrating their official sort of Spring Framework 5 support. So we've been working on this. This has been in the works for more than a year for most of these projects, and so you're going to see a lot of new releases coming up in the weeks and months ahead. And of course, Spring Boot 2.0 will in turn allow us to release a new release of Spring Cloud Finchley in the first quarter, we think, of 2018. And Spring Cloud has a new technology called Spring Cloud Gateway, which in turn builds on the reactive support here. So we can do a lot of amazing things now that we have a Java 8 and Lambda friendly baseline. Now that we have the reactive support in Spring Framework 5 as a foundation, and we hope that you'll take advantage of it. I want to thank you so much for all your time. I'm happy to answer questions, and don't hesitate to reach out to me and to find me on Twitter at StarbucksMan if you have questions, comments, or feedback. Otherwise, Andrea, I think I'll pass it back to you, my friend.
Thank you, George. Splendid. It was so impressive. I didn't even expect you to make it in Kotlin, so I'm so happy. We have a couple of questions.
Oh, please. Only 2, huh?
Well, so first, very minor questions. What makes reactive security reactive?
Yeah, so this is a great question. The reactive security stuff, we have context propagation. We had to change the way we do context propagation, and so that is a major part of the reworking. And then basically we've reworked some of the core interfaces to now work in terms of publishers. So where we can, we produce the authentication manager. Basically, we produce that asynchronously. We produce things like the user details repository as a publisher. Right? These things are values. These are values that we don't need to have on demand when we first initialize, and we don't need to have necessarily even until later on in the processing pipeline. So we defer until the last moment when this information becomes available. So there's a number of different things there. I don't purport to understand all of what's happening there. I just know that there's a lot of work that had to be done to unwind some of the default blocking assumptions. And also, of course, this works in a Spring Web Flux world. So we've reworked Spring Security to to work with the new filter model, to work with the processing lifecycle of the Spring Webflux runtime. Because remember, this is not a servlet-based application, whereas a lot of the existing sort of fundamental stuff that you would have worked with in Spring Security before wouldn't have worked in that. It required the servlet API.
Got it. Next question: can we use Kotlin coroutines to avoid spaghetti code? So before you comment on that, there is a third-party project called Spring Kotlin Coroutines by Konrad Kaminsky, used at Allegro, and but for official comment, yeah, I think it's better to ask Josh.
Well, so we don't have anything right now, but I think I saw rumblings of discussions about supporting that in Reactor itself, right? So that as a research thing. So that's certainly something I've seen talked about recently. It's not there yet, but maybe that third-party project might be interesting. I don't know.
Cool. There's a comment about the IDE support. What extra plugins does Josh use? I could not find Spring 5 support. So, well, first of all, Spring 5 support is available in the latest release and also in the, of course, the new one, which is available as a preview. But since Josh used Kotlin, so the IDE support depends on the support for Kotlin along with Spring, and this is partially already available in the latest release, but it's more to come in the 0.3 release, which is coming in 1 month.
Right. Yeah, I didn't have to use. I love IntelliJ, great tool, but let's be pretty frank here. This is just basic Java and public static void main, right? I used almost nothing. The Lombok plugin, I had to use that. That's a great plugin. For the Java code. For the Kotlin side, I used the impressive support for Kotlin built into IntelliJ. Although I give the folks at JetBrains a lot of credit. They also built a pretty good Kotlin plugin for Eclipse, isn't that right?
Yeah. Well, we work on that as well.
Yeah. So lots of it just works perfectly.
Cool. Next question about Spring Cloud and Spring Data Cloud. Does it, does Reactive Spring support them, or those are different concepts?
So Spring Cloud is being reworked to support wherever possible the reactive work that we've just demonstrated in this last hour. So Spring Cloud will support it. We already do have some support. For example, you can already return an ArcsJava observable, for example. So that's ArcsJava 1, I think. I'm not sure if it's ArcsJava 2. There's initial preliminary support. You can look at the latest builds of Spring Cloud Finchley. So Spring Cloud Finchley is not general availability yet, right? It will be, as I say, Q1 of next year. And we even have a brand new technology called Spring Cloud Gateway, which is a gateway technology that looks and does a lot of the same things as the Zool gateway or microproxy from Netflix. But it is built from the ground up using the Spring Webflux runtime. So it's reactive, and we provide a Spring-centric and Spring-friendly component and processing model. So there's a lot to admire in that, and I would recommend you take a look at that. So yes, it does support reactive support. It does support reactive programming wherever possible, and that's a big part of that is making Spring Boot 2.0 work.
Cool. Slightly related question. Can I use Reactive Spring with Spring Cloud and Zool to build an API gateway? Is it recommended at all?
You can use, so Zool, right now, Zool 1.0 doesn't have a reactive API. The filter model is not reactive. So I think there's work on that in Zool 2, but as far as I know, that's not quite out there yet, is it? It could be. So I don't know if you would do that, but I know you could do that with Spring Cloud Gateway.
Yeah. Okay. Also, if I want to work with a database that doesn't have an async driver, can I do that implementation using the block and switch that out when the database releases the async driver?
Yeah, I mean, you can work with whatever you want, but it's up to you to now manage moving that work out of the processing loop. And thus far, I've kind of just looked at the default, but it's worth understanding that there is actually a scheduler. We talked about that ever so briefly here. there's a scheduler behind the scenes, and that's one of the knobs and levers that you can manipulate to change things. So here is a publisher. Let me see. Then many. Let's see. Delete all. Schedule. Oops. Subscribe. Subscribe on. See that? See that subscribe on method that says subscribe on, and I can pass in a scheduler. That scheduler can be, schedulers dots. Any of these, I can put in. These are all thread pools, basically executors, things like that, that you can use to manage the sort of concurrency of this definition of this pipeline, right? So you can have more control over how the scheduler moves your work across different threads and so on. That's the nice thing about this, is that because we're writing this API, we're using this code. It looks very declarative and very imperative. We're saying delete, then do this, then do that, then do this. But there's no, this doesn't have to be sequential. There's nothing about this that is implicitly, well, except for the fact that these are then and then. But you can build pipelines that do all sorts of processing, and that work can be done in parallel if you so deem it required or necessary.
Well, okay. Next question: how Reactive Spring inline is in line with Java 9?
So Reactive Spring right now, Spring Framework 5 works with Java 9. The main feature that we have in Spring Framework 5 for Java 9 is the module, is Jigsaw, right? So there's nothing specific about the reactive support that we need to know about with respect to Java 9. Spring 5 works just fine. It works perfectly on the module path and on the class path in Java 9. That's that's one of the main features. We've also got, there's little updates here and there for little items in the JDK that have been updated that we see reflected in Spring Framework 5. But the main thing that you'll see is that we support the module system now. Don't require it, mind you, but we support it if you want it.
Cool. Well, there is a question about IntelliJ IDEA if it supports generates test methods for Kotlin as it does for Java. I believe it does. But yeah, I have to confirm with the team. In case if it doesn't, well, it's something.
Looks like it does. I just clicked on Command-Shift-T inside of my service there, and I've got this new create test method window dialog thing, and it says, would you like to create these methods? And I'm okay, sure. Hit okay. There we go. Look at that.
Cool. Yeah, it works. There are some questions which we can follow up on with the email. So I'm looking for most interesting ones. Do you have a hint to the people still working with MySQL and MariaDB? Not sure if we can comment on that.
Yeah, it's fine. I mean, if you don't have to use the reactive support, but if you have a use case where you're doing lots of I/O bound interactions, then the reactive support might be valuable for you. That said, if you're using something that's a SQL driver and that's fundamentally blocking and you're okay with that, that's fine too. We're not forcing people or moving people forcibly to one approach or the other. There's a time and a place for these different technologies. There is, as I say, no support right now for JDBC and JPA in the reactive world, but as Oracle announced this week, they've got work underway for a reactive JDBC driver. So hopefully that portends a better situation in the coming months or years for JDBC access.
Yep. Maybe final question because we run out of time. What's your opinion comparing with Kafka? So how does Reactive Spring compares with or intersects with Kafka?
These are neither here nor there. Kafka is a message queue. We have a project called Spring for Apache Kafka, and that is well supported at the Spring for Apache Kafka level, as well as by the integration for Spring integration. So we have an inbound and outbound adapter for that, and then of course we have Spring Cloud Stream binders for Apache Kafka. But Kafka is a message queue. It's a message broker, whereas the reactive support that I demonstrated here is just a way of composing pipelines inside of your single process. You could
Yeah.
surface that pipeline to other nodes, to other processes by using REST or by using something like that. But there's nothing necessarily that they don't necessarily connect or intersect.
Got it. So I think it's all the time we have for questions today, and we should wrap up.
Well,
Thanks,
thank you very
Josh,
much.
for your time. Yeah,
Pleasure.
really appreciate it.
Well, thank you very much for having me. It was so much fun. And again, I want to encourage people to reach out at josh@joshlong.com or at Starbucksman, STRBUXMAN, should you have more questions, comments, or feedback. Thank you so much.
Awesome. Thank you. And thanks, everyone, for joining us. Have a good day and take care.